Hi, in this video we're gonna discuss the evaluation of a limit. So basically how to calculate a limit. Okay, so let's just say the function we are dealing with is q equals to 2 plus v squared. Now, we want to find what is the limit of this function with v approaching 0. Okay, look, in such circumstance, we need to start with left-hand side limit. Well, at least at the beginning. Later, we will get some shortcuts and we know how to do it faster. Okay, so we get, so let's start by evaluating left-hand side limit. So limit with v approaching 0 from left-hand side out of q, which in our case is limit with v approaching 0 from left-hand side out of 2 plus v squared. Okay, look, how do we approach this problem? Now, let's consider what does it mean if v approach 0 from the left-hand side. Look, we said that v is basically getting closer and closer and closer to 0, but from the perspective, but from the numbers that are lower than 0. Look, how can we imagine this v getting closer and closer to 0? Look, for example, we can substitute for v some very small number, like negative 0.1. Look, very small, but still not that small, right? So, what other number could we substitute? How about negative 0.01? Then we see also what is happening over here. This number is getting smaller and smaller and smaller, right? Because negative 0.1 to the power of 2 is 0.01. Negative 0.01 to the power of 2 is 0.0001. And look, then we can substitute a smaller number, an even smaller number. Actually, we can go on like this until we put really imagine that we are putting here extremely tiny number. But of course, there's always a smaller number that we can put instead of v. And look, but this creates some pattern that we can actually predict. We see that as we put instead of v a smaller and smaller and smaller number, we are getting a number that is closer and closer to 0. And if we take a square of it, that makes even a smaller number. So we can see that actually, as v is getting closer to 0, v squared is going for 0. So look, in this case, we can say the limit is equal to just 2. Okay, then, of course, we need to evaluate right side limits. Okay, so we are evaluating right side limit for 2 plus v squared. And look, again, we can perform the same mental exercise. Look, we could provide a number that is close to 0, but still positive in this case because we are going on numbers bigger than 0 now. For example, 0.1, then 0.01, then 0.001, then one like this. And again, we imagine that we are putting here a number that is so ridiculously tiny that it's barely visible. Right? And of course we remember that even though here we have so many zeros, there is still even a tinier number than this one. But again, some pattern here emerges. As we put lower and lower values, we are getting closer and closer to 0. So again, we can see that this is going for 0. So the limit of this function is simply 2. Okay, and look, because left-hand side limit is equal to the right-hand side limit, and they are both equal to a finite number 2, then we can write that limit with v approaching 0 out of q exists, and it's equal to 2. Okay, so now let's start with another example. So now we've got that the function we are dealing with is q equal to 1 minus v squared over 1 minus v. Okay, and the limit we need to calculate is limit with v approaching 1 out of q. So we need to figure out how much is it or does it exist. Okay, and again, we can try doing the same thing. We can calculate the left-hand side limit. And out of q, so limit with v approaching 1 from the left-hand side out of 1 minus v squared over 1 minus v. Okay, and look, we can again perform the same mental exercise. I can substitute, instead of v, a number that is close to 1 but smaller than 1, right? For example, 0.9, then 0.09, then 0.009, 99, of course, I'm sorry, it's very early for me. So 0.9, 0.99, 0.999, and then we could get a number that is really close to 1 but smaller than 1. But of course we still remember that there is an even smaller number. And look, where is this going to? Now, we see that actually here, as v is approaching 1, we could basically substitute 1 over here, just like we substituted 0 before. But look, this creates a problem, because 1 minus 1 is equal to 0. And we cannot divide by 0. So there is some trick that we need to do over here to eliminate this problem. And look, here the trick will be to rewrite this expression, right? Because this is the same as limit with v approaching 1 from the left out of 1 minus v times 1 plus v over 1 minus v, right? And now look, those two cancel each other out, and all we have to do is to evaluate limit with v approaching 1 from the left-hand side out of 1 plus v. And look, now, as we perform this exercise, we see that if I'm going to be substituting here number closer and closer and closer to 1, I'm going to end up at 1. So I'm getting that this is just 2. Okay, now what about right side limit? Well, with the knowledge we already have, I can already rewrite this expression in this form, right? So we will have that this is a limit with v approaching 1 from the right hand side out of 1 plus v. So now I'm substituting this with a number that is slightly bigger than 1, like 1.1, 1, then, and we are getting closer and closer to 1, so we will have 1.01, then 1.0001, and then 1.000000000001, and we see that this number gets closer and closer to 1. So what is the limit? Limit is 1 plus 1, so it is 2. And because left hand side limit is equal to the right hand side limit, we can say the limit exists and it's equal to 2 again. Okay, so we've dealt with these two cases, but what about if we have a limit with v going to infinity or negative infinity? Okay, again, let's start with a very simple case, and then let's start making things. Let's make things a little bit more complicated later. Okay, so let's just say that we need to calculate a limit with v approaching infinity out of q that is equal to v squared plus 1. Okay, now again, look, we can perform the same mental exercise, but now we need to imagine infinity. How will we imagine infinity? We can imagine it as a big number, like 9, 9, 9, 9, 9, 9, 9, 9. And then we see that if we take this number to the power of 2, we're going to get even bigger number. And then we can increase this number and we see that as a result, we will get an even bigger number. So look, if we're going to be increasing this number indefinitely, the value of this expression is going to be increasing indefinitely. So the limit here is infinite. And what about the same function, but with v approaching negative infinity? So what number now should approximate negative infinity? How about negative 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, and so forth, right? Now, if I'm going to take this number and I'm going to raise it to the power of 2, what am I going to get? Positive number, because this is square, and even a bigger number. So look, again, we see that the limit here is infinity. Okay, and how about if we get to calculate limit with v approaching infinity out of 1 over v. Let's start with something very simple. Okay, so what do we see over here? Look, now, again, I can approximate our v with a bigger and bigger and bigger number, right? What is happening to 1 when we divide it by a bigger and bigger and bigger and bigger and bigger number, well, it gets smaller and smaller and smaller and smaller. If number is big enough, we are getting closer and closer to 0. And look, this is the limit in this case. It's just 0. Okay, so let's try now. Let's just say that we need to calculate a limit with v approaching infinity out of, let's just say, 3v to the power of 5 plus 7 v to the power of 3 plus 2 over 4 v to the power of 6 plus 4 v to the power of 2 minus 1. Okay, look, here there is one very tempting thing you could do. Look, we clearly see that as v approaches infinity, this expression gets bigger and bigger and bigger and bigger. It is going to infinity, right? Now, this number, as it gets bigger and bigger and bigger and bigger, as v gets bigger and bigger and bigger and bigger, gets also to infinity. So, well, the tempting thing to do here is to say, well, it is equal to infinity over infinity. So, they cancel each other out. This is just 1. Beautiful. Well, of course, this answer is totally wrong. Why? Because, as I hope you remember, infinity divided by infinity is an unidentified symbol. We don't know how much is it. Because look, this infinity is a different number than this infinity. And I'm going to actually show you that in this case, the limit is just 0. Okay, how can we get this result? Look, first thing that we can always do is that we can take 1 out of any expression. In this case, out of this fraction. But look, 1, okay, let me just write the limit with v approaching infinity, and is the same as 1 times 3v to the power of 5 plus 7v to the power of 3 plus 2, right? Times 4 to the power v to the power of 6 plus 4v to the power of 2 minus 1. Okay, this is of course true. But look, 1 can be expressed in various different ways. It doesn't necessarily need to look like 1, because for example, v divided by v is definitely equal to 1. But look, what I'm going to do now here is I'm actually going to take out of this fraction v to the power of 6 divided by v to the power of 6. Okay, so what am I actually doing here? Look, what I am doing here is I'm dividing each expression within this fraction by v to the power of 6. Right? Those two, of course, cancel each other out, and we just get 1. Okay, so now let's see how is this expression gonna look like. Okay, so we've got limit with v approaching infinity out of, and look, over here, I'm gonna have 3 over. And look, v to the power of 5 divided by v to the power of 6 is equal to 1 over v. So this is 3 over v. Then we've got plus 7 divided by v to the power of 3 divided by v to the power of 6 is v, 1 over v to the power of 3. And here we just get 2 to the power, 2 divided by v to the power of 6. Over here, 4 times v to the power of 6 divided by v to the power of 6. Those again are giving us 1, so we just got 4. Okay, now over here we've got 4 times v to the power of 2 divided by v to the power of 6, which is 4 divided by v to the power of 4. Now, over here, finally, we've got minus 1 over v to the power of 6. And look, now we are actually ready to evaluate this limit. Because look, as v is growing indefinitely, which means it's getting bigger and bigger and bigger, this is the case we had over here, right? Where does it go? Well, it goes to 0. Now, 7 by v to the power of 3, this means that it grows even faster, right? So, if we divide by an even bigger number, it definitely goes to 0. Over here, we divide 2 by v to the power of 6, all definitely goes to 0. 4, well, just 4, right? So, over here, we've got 4 divided by v to the power of 4. Again, this goes to 0. And finally, minus 1 divided by v to the power of 6. This goes to 0 as well. So, what we get out of this is that we've got 0 divided by 4, which is permitted operation, of course, and it is equal to 0. Okay, let's try one more. I hope you're getting the hang. Okay, so the next example we're going to do is with when we have to calculate limit with v approaching infinity out of, let's just say, 3v to the power of 7 plus 6v to the power of 5 minus 3v to the power of 4 minus 4v. Okay? Then we've got over 2v to the power of 7 plus 6v to the power of 6 minus 7v to the power of 2 plus 1. Okay, and look, we're going to use exactly the same trick to deal with this case. So, what we're going to do over here is to take out v to the power of 7, which is the highest power, divided by v to the power of 7. Okay, so what we're going to get, we will have limit with v approaching infinity out of 3 plus 6 over v squared minus 3 over v to the power of 3 minus 4 over v to the power of 6 divided by 2, right? Because v divided 2 times v to the power of 7 divided by v to the power of 7, then plus 6 over v minus 7 over v to the power of 5 plus 1 over v to the power of 7. And now, what do we see over here? This goes to 0, right? This goes to 0. This goes to 0. This goes to 0. This goes to 0. And this goes to 0. Okay, so how much do we get at the end? Look, the only thing left is 3 over 2. So the limit is equal to 3 over 2. Okay, so look, this is in a nutshell how we calculate the limits. You need to practice it a little bit more to get a proper hang of it, but this is what you're going to be doing during workshops. Okay, thank you and see you in the next video.